This is Geometry B, Unit 1, Lesson 4, and I'm just going to do a brief summary of the concepts in this unit as kind of a preview or a post view, however you choose to use this. It's parallel and perpendicular lines. The situation is this. The situation that this lesson is about is when you have two lines that are crossed by a transversal. Crossed by a transversal. Two lines crossed by a transversal. And lines don't have to be parallel. When you have two lines that are crossed by a transversal, you have several pairs of angles that have names. Okay? The first pair of angles are corresponding angles. Corresponding angles are angles oriented in the same place relative to each other at different intersections. So angle 1 and angle 5 are corresponding because they're both in the upper left of their intersection. Okay. Likewise, angle 2 and angle 6 are both in the upper right, so they are corresponding. Okay. So hopefully that makes sense. Corresponding. So angle 1 and angle 1 and angle 5. As an example, angle 3 and angle 7 are another example because they're in the bottom left. Corresponding angles, same orientation in different intersections. Okay. Then there are alternate interior angles. Alternate angles are on opposite sides of the transversal. Interior are inside. So they are alternate. They're on opposite sides. They cross over. And interior, they're between the two crossed lines. So angle 3 and angle 6 are alternate interior because they cross over the transversal and they're interior. 3 and 6 are alternate interior angles. So angle 3 and angle 6. Also, angle 4 and 5 are alternate interior angles. Angle 4 and angle 5. Okay? And then if we have alternate interior, alternate interior, we have alternate exterior. Alternate exterior. And they are outside the crossed lines and cross over the transversal. So 1 and 8 are alternate exterior angles. Angle 1 and angle 8. Angle 2 and angle 7 are alternate exterior angles. They're outside the crossed lines and they're on opposite sides. Alternate exterior angles. Angle 2 and angle 7. Okay? And then we have same side interior. Same side interior. So they're on the same side of the transversal, like on the left or the right, and they're interior. So 4 and 6 are same side interior angles. Angle 4 and angle 6. Okay. Also angle 3 and angle 5 on the left side there. Angle 3 and angle 5. Okay. Same side interior angles. And then there is, if there's interior, there's same side exterior angles. Same side exterior. So they're outside the crossed lines and they're on the same side. So angles 2 and 8 are same side exterior angles. And angles 1 and 7, same side exterior angles. Okay? And that's about it. That's the names of the pairs of angles that you're responsible for knowing. Now what if we have the lines parallel, right? What if the lines are parallel? And we're going to answer that question here. So let's redraw this. we draw this so that the lines are parallel. And there are some rules, we call them postulates because we take them without proof. Okay? Actually, we take one of them without proof. So if the lines are parallel and they're crossed by a transversal, okay, 1, 2, 3, 4, 5, 6, 7, 8. So if the lines are parallel, then we say this. Then we say corresponding angles like 1 and 5, they're the same. They're congruent. Corresponding angles are congruent. That's a postulate. Alternate interior angles like 3 and 6, they're the same size. They are congruent. Alternate exterior angles like 1 and 8, they're the same size. They're congruent. Same side interior angles like 3 and 5 are not congruent, but they are supplementary, meaning they add to 180 degrees, right? They add to 180. So 3 and 5 are supplementary. Forgot to undo that. So add to 180. Same side exterior angles like 2 and 8. They're not the same, but they're the same. They are supplementary. They add to 180 as well. Okay? So basically what happens here is 3 is the same as 2. They're vertical angles. 3 is the same as 6. They're alternate interior angles. 3 is the same as 7. They're corresponding angles. And 6 and 7 are vertical angles. So all 4 of those angles, 2, 3, 6, and 7, are congruent. Likewise, 1 and 4 are congruent, and 5 and 8 are congruent, and 1 and 4 are congruent to 5 and 8. Right? So we can fill in. If we knew one of the angles, we would actually know all of the angles. And that's really kind of a cool application. So if angle 2 is 60 degrees, then 3 is 60 degrees, then 6 is 60 degrees, and then 7 is 60 degrees. Moreover, we also know angle 1 because angles 2 and angle 1 form a straight line, linear pair. Linear pairs are supplementary. They add to 180. 180 minus 60 is 120. So 1 is 120, 4 is 120, 5 is 120, and 8 is 120. So just knowing one angle in this situation, if the lines are parallel, is sufficient to find all 8 of the angles, just knowing one angle. Okay. Now there is something called the converse. Remember, a converse of an argument switches. So if the lines are parallel, then all these facts are true. If these facts are true, then the lines are parallel is also the case, right? And so we have situations like this, where we will be given some angles and asked, are the lines parallel? Okay. Are the lines parallel? So I'm going to draw them not parallel. Little askew there, okay? And let's say this angle is 80 degrees, and this angle is 80 degrees. And you're asked, are the lines parallel? The answer would be yes, they are, because corresponding angles are congruent. Okay? If this angle is 80 degrees and this angle is 80 degrees, are the lines parallel? The answer is yes, because alternate exterior angles are congruent, right? If this angle is 80 and this angle is 100, are the lines parallel? Well, they're same side exterior angles and they're supplementary. So, same side exterior angles are supplementary, therefore the lines are parallel. So the converse of these statements is also true. Okay? And there are a number of proofs along this line. I'll do one proof here. So here's the proof I'm going to do. We're given this situation. We've got a pair of lines that we don't know if they're parallel. Okay? We don't know if L and M are parallel. Okay, but they're crossed by a transversal. They're crossed by a transversal. And we're told this information. We measure some angles and we discover that angle 1 is congruent to angle, let's say, it's supplementary. It's supplementary. Angle 1 and angle 2 are supplementary. So we're given measure of angle 1 plus the measure of angle 2 is 180. And we want to prove L is parallel to M. Okay? And you remember how to do a proof. Statements go on the left. Reasons go on the right. Okay? And remember, you can always start, if you don't know where to go, where to start, always start with the given. So statement number 1, measure angle 1 plus measure angle 2 equals 180. You should always be able to do that. Given. And let's jump to the end. I don't know what step number it's going to be. Okay, but somewhere down here at the end, we're going to have L is parallel to M. And the reason is not proof. The proof is never a reason. But we're going to have a reason when we get there. L is parallel to M. Okay, to do this, I'm going to label some additional angles here. I'm going to label angle 3 right here. Okay. And here's what I'm going to do, and this is not the only proof of it, but it is a logical one. Step 2, angle 1, actually I would say this, measure angle 1 plus measure angle 3 is 180. How do I know that? They are a linear pair. So it's called the linear pair postulate, or you can just state what the rule says. Linear pairs add to 180 or are supplementary. Okay, linear pairs are supplementary. So measure 1 plus measure 3 equals 180. All right, so it's step 3. Measure angle 1 plus 2 is 180. 1 plus 3 is 180. So 1 plus 2 equals 1 plus 3. How do I know that? That's called the transitive property. Two things equal to the same thing equal each other. Transitive property of equality. If they both equal 180, they equal each other. Right? They both equal 180, so they equal each other. Okay, now here's, let's go here. So 4. I can subtract, measure angle 2. Subtract measure angle 2 from both sides. We get measure angle 1 equals the measure of angle 3. Okay, and the rule that allows us to do that is called the subtraction property. And this is supposed to be 1, this is supposed to be 2. Okay, subtraction property, and feel free to use abbreviations in your proofs. Measure of 1 is equal to measure of, whoops, haha, I messed up. 1 plus 2, 1 plus 3. Back it up. All right, yeah, that's annoying. I'll stop. It was 1 plus 3. Okay, measure angle 1 plus 3. 1 plus measure angle 3. So what I wanted to do is subtract 1 from both sides. Okay, measure angle 2 equals measure angle 3. There we go. And that's step 4, and that's the subtraction property. of equality. And therefore, 5, angle 2 is congruent to angle 3. They have the same measure, right? 2 is congruent to 3. And 5, how do I know? That's what congruent angles are. The definition of congruent angles. Use symbols for words, for sure. And 2 and 3 are corresponding angles. So the rule we've just learned here is step 6. L is parallel to M because corresponding angles are congruent. In other words, by the converse of the corresponding angle postulate. Converse the corresponding angle postulate, which says if corresponding angles are congruent, lines are parallel. All right. So hopefully that helps. Feel free to book a live lesson if you need any more help.